Hello everyone, welcome back to our channel. In today's session, we'll explore how to create an AWS ECS, which is Elastic Container Service cluster using Terraform. So Terraform is a popular infrastructure as code tool. So with the help of Terraform, we will create ECS on our AWS account. So today we will learn about what is ECS, then we'll explore about the architecture of Amazon ECS service. Then there are some prerequisites you should need to follow, such as you need to have an AWS account with an Prime user, and the AWS credential should be set up locally with AWS config and a code or a text editor like Visual Studio Code. So I am currently using Visual Studio Code. And once we have finished all the prerequisites, we can start writing the code to create ECS cluster. So there are some steps for deploying AWS ECS using Terraform. So it includes steps like to create provider.tf file, to create virtual private cloud in AWS, to create IAM role, and to create Elastic Container Registry where we need to add our image. Then we will create the task definition, the ECS cluster, then the service, and then we will verify the result on our AWS console, then followed by the conclusion. So let's start. So what is Amazon ECS? So Amazon ECS is a fully managed container orchestration service that allows you to run, stop and manage Docker containers on a cluster. So it takes care of underlying infrastructure including the provisioning and scaling of resources, allowing you to focus on your application. ECS is designed to work seamlessly with other AWS services, providing a comprehensive container management solution. Now we will learn about the architecture of Amazon ECS. So you can refer this article, which is available on fasttechniques.com, where you can find the Terraform code as well as the architecture of the Amazon ECS service. So this is the architecture of Amazon ECS service. So Amazon ECS architecture comprises of several key components that work together, facilitate the deployment and management of containerized application. So it includes components like ECS cluster, are the logical groupings of EC2 instances. So AWS Fargate containers and other resources where containerized application are deployed. Then the container instances. So EC2 instances or AWS Fargate containers within a cluster that will host containers and are registered with ECS. Then we need to specify the task definition, which is the blueprint specifying parameters for containers including Docker image, CPU, memory, and network setting. Then after this, we need to specify the task, which is this is under the task definition representing the execution of containers on a container instance within the ECS cluster. Then we need to specify these services, which will manage containers running and scaling of tasks, ensuring desired task count and handling lifecycle management. Then, with the help of scheduler, ECS coupled which is responsible for placing tasks on EC2 instances or AWS Fargate containers considering resource requirements and availability. We can also use Elastic Load Balancer to distribute the incoming traffic across multiple containers within an ECS service for high availability and efficiency. And we will use Amazon ECR, which is Elastic Container Registry, which is fully managed Docker container registry integrated with ECS for secure storage, management, and deployment of container image. So basically, the container image is a lightweight standalone executable package that includes everything needed to run a piece of software managed and stored in registries like Amazon ECR, which is Elastic Container Registry. Then, as you can see, we require VPC. So VPC is nothing but the virtual private cloud, which is a logically isolated section of the AWS cloud where ECS cluster and other AWS resources operate. So it will provide control over the network environment. And what is AWS Fargate? So it is a serverless compute engine for container that abstracts away infrastructure management, allowing for simplified deployment and operation of container. And we will host EC2 instances. So it is basically a virtual server in the cloud, forming the foundation of ECS cluster. So they will host containers when using with EC2 launch type. So this is the basic architecture. Now let's move forward and see the steps for deploying AWS ECS service using Terraform. So as you can see, if you zoom this, here you can find the file structure. So I have created a folder called as Terraform ECS and I have saved all the files in that folder. So here you can find the file structure. So we will go step by step and create the resources required to create ECS on our AWS account. So let's begin with step. So step one is to create the provider.tf file. So the provider.tf file in Terraform basically is a configuration file that will specify the cloud provider and its corresponding plugin that Terraform will use to manage resources in that provider. So you can find the code in my article, which is available on posttechniques.com. So you can simply copy this and paste it on your Visual Studio Code editor. So here you can find the Terraform configuration will file specifies the following. So the required providers will define the provider requirements for the Terraform configuration. So in this case, it specifies that the configuration requires the AWS provided from HashiCorp with a version constraint approximately to 5.0 and the provider we are currently using is AWS. So which will configure the AWS provider with the specific setting. So I have used the region called as AP South 1, which is Mumbai. And the profile is set to default as it will specify the AWS CLI profile to use. So the profile name default will be used, which typically correspond to the default credential and configuration stored in the AWS credential file. Now our next step is to create a VPC in AWS using Terraform. So just click on this and type your vpc.tf file to create a file. So same as you can create all other files. So our next step is to create VPC. So you can find the code and copy the code and paste in the Visual Studio Code editor. So I have named the file as vpc.tf and the resource I have used is AWS default VPC. You can also use Terraform registry to create VPC. So to create VPC, I have used the resource AWS VPC default VPC and given the name for the default VPC as ECS VPC. Then I have created a subnet. Then I have created a subnet. So basically, the AWS default subnet ECS AZ1, which is the availability zone 1, which will create resource default subnet in availability zone, which is here you can see availability zone is AP South 1A. So the availability zone will attribute specifies the AZ, and the tag block assign a tag to the subnet with the key name and the value is default subnet for the AP South 1A for identification purposes. Same as the above, similar to the previous resource, this will create a default subnet in availability zone AP South 1B and AP South 1C. So we have successfully created the VPC and the corresponding subnets. Now our next step is to create an IAM role. So simply we need to add im.tf file here. So simply click on this and just write here iam.tf file. So which will create a file. So as I've already created, so our third file name is im.tf file. So as to create an IAM role named ECS task execution role, we need to create im.tf file. So you can copy the code from our article and paste on a text editor. So as you can see, the resource I have taken to create an IAM role is AWS IAM role and the name is ECS task execution role. So basically, this Terraform configuration will define IAM identity and access management role named ECS task execution role and with the associated role policy document that specifies the permission and condition under which the role can be assumed. So as you can see, the IAM role, here you can find the AWS IAM role will specify with the name which I have given as ECS task execution role, and the assume role policy will refer the IAM policy document that will define who or what entities can assume take on this role. So it refers to the data source. Here we have created the data source, and the IAM policy document. So basically, this data source will define the policy document that allows the specified service principal ECS task Amazon AWS.com to assume the IAM role. And the statement will define a statement within the policy document. And the action will specify the action that are allowed or denied by the statement. So in this case, it allows the action assume role which is required for assuming the role. And the principal will specify the entity or entities that are allowed or denied by the statement. So here it specifies the service principal or type service with the identifier ECS task.amazonaws.com, indicating that ECS task can assume this rule. So basically the purpose of this configuration is to create an IAM role named ECS task execution role with a specific assume role policy. So basically, this role is typically used by ECS, Amazon Elastic Container Service, task to obtain permission to perform action within an AWS environment. So by defining the assume role policy, you specify which services or entities are allowed to assume this role, ensuring that only authorized entities can leverage the permission associated with the role. So this will help in maintaining security and access control in AWS environments by following the principle of least privilege. Now let's move forward and see the next step. So our next step is to create Elastic Container Registry file. So simply add here ecr.tf file. So I have already added. So basically this Terraform file will manage AWS ECR repository for storing container images. So just copy this code and paste in the ecr.tf file. So as you can see, the, the resource, as we need to create an ECR repository, so the resource I have taken as AWS ECR repository, and the name I have given as my first ECR repo, which means repository. So this Terraform configuration will define an Amazon Elastic Container Registry repository resource named as my first ECR repo. So here you can see the tag name I have given as latest ECR. So this is just to create a repository in Elastic Container Registry. So the purpose of this file is to create repository with a tag name, and ECR repository are used to store the Docker container images, and which they can provide a central location for managing and versioning container images in AWS. So the specified name and tags are used for identification, organization, and management purpose within the AWS. Now we have added the repository on our Elastic Container Registry successfully. Now our next step is to create the task definition.tf file. So now copy the code for task definition and paste it in the editor. Now here, to create a task definition, I have used a resource named as AWS ECS task definition, and I have given the task definition name as my first task. So this Terraform file will define an AWS ECS task definition for containerized application. So I have basically given the name as task definition.tf file. So as you can see, the resource name is AWS ECS task definition with the identifier named as my first task. So the resource type is the task definition, which is used to define the configuration for the ECS task. And below this here you can find the family name for this task definition is my first task. And the container definition block will define that the containers that will run as a part of the task. So it uses multi-line string, which is the definition, to provide a JSON formatted container definition. So the definition includes the name, which will specify the name of the container within the task. So which is my first task, and the images, the image, which will specify the Docker image to use for the container. So it references the repository URL of the ECR repository defined earlier. So here we have defined the repository. Now next, the essential is set to true, which indicates whether the container is essential for the task. So in this case, as it is set to true, meaning the task won't start if the container fails. Then there is a port mapping parameter the which will define the port mapping for the container. So mapping container port 80 to host port 80, and the memory and the CPU. There you can find the memory and the CPU. So the memory and the CPU will specify specify memory and CPU resources for the container, and the network mode will specify the network mode for the container. So here it's set to AWS VPC for the AWS VPC network. and the definition will require the compatibilities. So it is set to EC2. So this will specify that the task definition is compatible with the EC2 instances. And the other option include Fargate for Fargate compatibility. So the network mode specifies the network mode for the task. In this case, it matches the network mode specified for the container, which is AWS VPC. And the memory is set to 512 and the CPU is set to 256. So this will specify the memory and CPU resources for the task itself. And the execution rule, which will specify the IAM role here in that case the ECS task should use for the permission. So it references the IAM role defined earlier. So here you can find the IAM role which we have defined earlier. So now we have finished with the task definition. Now our next step is to create ECS.tf file. So which will include to create ECS cluster. So you can copy the code from our article to create, and you can also use Terraform registry. So this is the Terraform registry, the official Terraform documentation page where you can refer the code. If you click on the documentation and just click on the just type your resource name, which is AWS ECS, and if you look out, just type the resource name here. Here you can find the resource elastic container, and if you click on this you can find the code, and you can just copy and paste to create the ECS cluster. And you can also refer my article to create the ECS cluster. So just copy this code and paste in the editor. So here you can find as to create the AWS ECS cluster, just I have used the resource name as ECS cluster, and then I have given the name, the reference name as my cluster, and the name I have given as my ECS cluster. So it is simple to create ECS cluster. So basically the Terraform code will create an ECS cluster named as my ECS cluster, and ECS cluster is a logical grouping of ECS container instances. So where we can run and manage containerized applications. So clusters help organize and manage ECS resources, including tasks, services, and container instances. So I have given the name as ECS cluster.tf file. Then I have entered the code which will create the ECS cluster on our AWS account. Now our next step is to create the service.tf file. So this Terraform file will manage AWS ECS services for deploying and managing containers application. So you can refer the code, just copy and paste in on a text editor. So here we will break down the components one by one. So first is the resource. As I have to create the ECS service, I have taken the resource name as AWS ECS service. And so this line will declare on AWS ECS service resource with the identifier my first services. So the resource type is AWS ECS service, which is used to manage ECS services. Then I have named it as JFT test first services. So basically this line will specify the name of the ECS service that will be created. Then I have just mentioned our previously created AWS ECS Cluster ID and the task definition. Then I have launch type set to EC2. So this will specify the launch type of the service. So as in this case, we'll set it to EC2 indicating that the service will run on ECS container instances launched on EC2 instances. And the scheduling strategy is set to replica. So this will specify a scheduling strategy for this service. So replica indicates that the service should maintain a specified number of running tasks based on the desired count, and the desired count is 1. Then I have specified the network configuration. So as the design, so as you can see, the desired count is 1. So this will specify the desired number of tasks to run for the service. So in this case, it's set to 1. So meaning the service should have 1 task running. And below this, the network configuration. So this block will define the network configuration for the service, including the subnet and the public IP setting. So the subnet I am currently using is ECS as the 1. So you can find that it is AP South 1A availability zone. And then the assigned public IP is set to false. So it will specify whether the task in service should be assigned public IP address. So in this case, it's set to false, indicating that task will be not assigned public IP. So we will change this to true. So which will assign the public IP to our service. Now our next step is to create an now our next step is to create an AWS ECS cluster using Terraform. So we have finished with the required file to create the cluster. So now you just need to enter all the Terraform commands to create resources on our AWS account. So let's begin. So just right click in this and open an integrated terminal. So before this, you need to configure all access key and secret key. So because of this, we can create resources on our AWS account. So please make sure that you need to configure your AWS account. So just type Terraform init, which will initialize all the provider plugins. So as you can see, Terraform, so basically the Terraform init command is used to initialize a new or existing Terraform configuration. So this command will download the required provider plugin and set up the backend for storing the state. So here you can find the state file. So after now, our next step is to type Terraform plan. So the Terraform plan is used to create an execution plan for the Terraform configuration. So this command will show what the resources Terraform will create, modify, or delete when applied. So simply press enter. So as you can see, 9 resources to add, 0 to change, and 0 to destroy. Here you can find the resource name which we have specified in our Terraform configuration. So now you can find, just clear this. Now our next step is to apply, is to type Terraform apply command. So basically, this is to apply the Terraform configuration and create or modify resources in the target environment. So just type auto approve. So it will take automatically the permission for yes, and it will create the resources. Now as you can see, all the resources are in creating state. So it will take around 5 minutes to create ECS cluster on an AWS account. Previously the error was about the assigned public IP. which we have set to true, as it is not supported. Public IP is set to true, which is not supported for this launch time. So please set it as false. So here you can find all the resources which we have created through Terraform files have been created in AWS successfully. Now we will verify this on our AWS console. So here in the services section, just type here ECS and just click on the ECS. So here you can find that here we have mentioned, if you find the ECS cluster TF file, we have mentioned the name for our ECS cluster is my ECS cluster. So here you can find that resource have been created successfully. So if you click on this, it will give all the cluster overview, which include the status, the task, etc. And here you can find the services. Here in the service.tf file, we have mentioned the service name as test first service. So here you can find the service name, and you can also monitor it, such as for CPU utilization and memory utilization, the health of the service. So, and you can also find in registry. If you click on repository, we have also created repository. Here you can find the ecr.tf file where we have created our first ECR repository and named it as my first ECR repo. So if you click this, you need just to add, you need, as here you can find there are no images, you just need to push, you can push the command, use this command and push your image here. So we have successfully created ECS through Terraform. So after this, now just delete all the resources if you have completed with the practical. So just to delete, just type here destroy. So which will destroy all the resources created. So it will take around 4 to 5 minutes. So here you can find our destroy has been completed and total 9 resources have been destroyed successfully. And if you refresh this, you can find that there are no cluster available as we have deleted all the resources. So we have completed with the practical. So we will conclude for today. So in conclusion, Terraform provides a powerful and efficient way to manage Amazon ECS cluster. By defining infrastructure as code, users can easily create, update, and manage ECS cluster in a repeatable and automated manner. So this approach will ensure consistency, reduces manual errors, and streamlines the development deployment process for containerized application on AWS ECS. So you can find all the related articles such as to create Amazon ECS cluster manually and to deploy a Node.js app on Amazon ECS with the help of Fargate. So you can also refer this article. So thank you for watching the video, and please do subscribe our channel and like and share the video. So see you in the next video. Thank you.